Fossil fuels are slowly going out of style in the electric vehicle revolutions. Next, of course, there's Tesla leading the charge, thanks to tech visionary Elon Musk. But what's powering these silent speed demons? The battery, the very heart of every EV. Critics might laugh. Aren't EVs just a resource drain in disguise? To check this out, let's talk about how a Tesla battery is made, and whether it's the key to a greener future. While many components in EVs share similarities with traditional gasoline cars, the battery stands out as the main difference. Unlike internal combustion engines that rely on burning fuel, an EV draws its power directly from a massive battery pack. But forget the lead-acid batteries found in your average gas-powered car. Tesla, like most modern EVs, uses lithium-ion batteries. While larger and heavier than gasoline-powered car batteries, Tesla's lithium-ion packs offer more reliability and an increased lifespan. Think of the batteries that energize your laptop or smartphone, but on a much bigger scale. So beneath the sleek body of a Tesla, there's a battery pack made from thousands of individual lithium-ion cells. It's important to remember that these batteries don't contain pure lithium metal, but rather lithium ions, atoms or molecules with an electric charge. We start the process with sourcing raw materials, like lithium, cobalt, nickel and aluminum. These come from mines and processing plants. Now, these lithium-ion batteries aren't your corner store double-A batteries, they are small power plants inside. There are three key components. First up is the anode, the negative electrode. Often made of graphite like what's in your pencil, it releases a flood of lithium ions. Then there's the cathode, the positive electrode. It's made of a metal oxide, which is just a fancy way of saying metal combined with oxygen. Its role is to welcome the lithium ions and store them for later use. Finally, the electrolyte. This special solution allows the lithium ions to flow freely between the anode and cathode. This flow creates the electric current that moves your Tesla forward. Here's the coolest part. Tesla doesn't need to tear down mountains to get lithium for these batteries. Usually lithium's found underground of brine pools. Like giant natural batteries beneath the Earth's surface. The lithium-rich liquids pumped out and simply dried in the sun. A much more sustainable approach. Once extracted, the lithium is processed into lithium carbonate, ready to be transformed into the power that keeps your Tesla running. Tesla batteries have to go through a lot of tests throughout the manufacturing process. Individual cells are examined after production to ensure they meet strict performance and quality standards. Engineers measure factors like capacity, voltage, and internal resistance to identify any weak links. Only cells that pass these tests move on to become part of the bigger picture. Once individual cells are deemed worthy, they are grouped together to form modules. Multiple cells are connected using bus bars to achieve the required voltage and capacity needed to power the Tesla. An important addition at this stage is the thermal management system. This network of cooling elements makes sure the battery pack stays within a safe operating temperature range. After the module assembly, they undergo their own battery of tests. Literally, modules are exposed to extreme temperatures, vibrations, and other stresses to simulate real-world conditions. This testing helps identify any potential weaknesses in the module's functionality and safety before they become a problem on the road. After passing these tests, the modules are integrated into a larger casing, forming the final battery pack. This pack also houses the battery management system (BMS), the brain of the operation. The BMS acts as a conductor, constantly monitoring and controlling the battery's charging, discharging, and temperature. Finally, after passing all these tests, the battery pack is placed at the car's bottom for optimal stability. The final stage is all about assembly. It takes all the pieces, the battery modules, electrical connections and cooling systems, and brings them together. Some factories use a high-tech robot assembly line, while others have skilled technicians conducting the process and assembling. These packs can account for up to 14% of the total battery cost. Tesla tailors these battery packs to each car model. Kind of like designing a custom costume for the performance. They are often assembled close to the car factory for a smooth transition once installed. These battery packs become the heart of the electric Vehicle producing zero emissions. A clean getaway compared to gas-powered cars. The good news, these battery packs are built to last, with each one designed to retain its power for 100,000 to 200,000 miles. But here's the thing. Extreme charging habits or hot climates can take a toll, shortening their lifespan. Still, even when a battery pack can't power your car anymore, its story isn't over. These gently used batteries can be repurposed for other demanding jobs. One big opportunity is energy storage. These repurposed car batteries can help store energy from renewable sources, like solar or wind power. This stored energy can then be used at night when the sun isn't shining or the wind isn't blowing. So even after powering your Tesla, these batteries can keep the lights on and help reduce reliance on the traditional power grid. The potential goes even further. Factories that produce electric vehicles could one day be powered by banks made from retired car batteries. It's a closed-loop system, where the batteries come full circle. No wonder electric vehicle manufacturers are investing heavily in giving these batteries a second lease on life. Plus, companies like Nissan are leading the charge with their X-Storage program. They are taking retired Nissan Leaf batteries and turning them into energy storage systems for homes and businesses. They've even used these batteries to provide backup power for the Amsterdam Arena. The future is bright for these batteries. When they finally reach the end of their second life, they'll be recycled, recovering valuable materials and minimizing environmental impact. As electric vehicles take over the roads, reducing emissions and noise pollution, the race is on to find even better recycling methods to unlock their full green potential. Remember those old lead-acid batteries from gas-powered cars? Easy to recycle, but Tesla's electric car batteries are a different story. These packs are made of hundreds of smaller cells, and taking them apart needs a lot of work. And you've got to be super careful. They contain special materials and, if mishandled, could explode. Here's the challenge. Currently we can only recycle about half the materials in these batteries. That's not good enough, especially as more and more Teslas hit the road. But Tesla's on the case. They are taking apart old batteries and recovering things like coolants, wires and even electronics. The valuable materials get shredded, dried and sorted, almost like creating a new battery from the old one. And Tesla isn't alone. Scientists and other car companies are joining the race, figuring out faster and better ways to recycle these batteries. New recycling facilities are popping up too, all with the goal of giving these batteries a second life. The future is bright. With a little collaboration and innovation, we can unlock the full potential of Tesla batteries, not just for powering our cars, but for a cleaner and greener world. And that's all from us. If you enjoyed this video and want to know more about how objects are made, check out other videos on our channel. Stay curious and thanks for watching.